Hello everyone. In the last session we learned how to evaluate a triple integral. Now in this session we are going to know or we are going to solve problems on double integral over a given region. So before going to solve the problems, we should know some standard curves. The standard curves are straight lines, equation of a different types of a straight line, and equation of a circle, and equation of a parabola, and also ellipse. So we have a different types of a straight line. So if we have an equation x equal to 0, then that represents the equation of y axis. And also if we have y equal to 0, it stands for an equation of x axis. Y equal to 0 stands for the equation of x axis. And also if we have y equal to m into x, then y equal to mx is an equation of a straight line passing through origin. So whenever they given you y equal to mx, then we should draw a line which passes through the origin with a slope equal to m. And if I have y equal to x, then this represents again an equation of a straight line. Again it passes through origin, making an angle pi by 4 with x axis. So your slope reduces to 1. So the difference between the equation y equal to mx and y equal to x is, in this the slope of the line will be 1 because it passes through origin and it makes an angle pi by 4. Therefore we know that m equal to tan pi by 4 is a slope. So tan pi by 4 equal to 1. Therefore your m reduces with a 1. And we have x by a plus y by b equal to 1. This represents the equation of a straight line, which is nothing but an intercept form of the line. This is intercept form of straight line, where a comma 0 and 0 comma b are the points on x and y axis respectively. That means it makes an x intercept is a and y intercept is b. And also we have x minus x1 into x2 minus x1 equal to y minus y1 into y2 minus y1, which represents the equation of a straight line if we know the 2 points. So this is also called as a 2-point formula for the equation of a straight line. The next one is x equal to h represents the equation of a straight line which is parallel to your y axis. X equal to h is equation of a straight line parallel to y axis. So whenever they given you like x equal to some constant value 2, 3, 4 etc., then it is nothing but the equation of a line which is parallel to y axis. And also if I have y equal to k, then this represents the equation of straight line which is parallel to x axis. So these are the different types of a straight line. Okay. Then second one is a circle. So we have a 2 types of a circle. In that first one, x square plus y square equal to a square. So this represents the equation of a circle with center at origin center is 0, 0 and radius equal to a. Radius of the circle is a units, right. Another one is the standard curve x minus h whole square plus y minus k whole square equal to r square. This is the one more equation of the circle where the center of the circle is h comma k and the radius is r. So if we have a center other than origin, that means h comma k, then the equation of a circle is given by x minus h whole square plus y minus k whole square equal to r square. And then the third one is ellipse. That is x square by a square plus y square by b square equal to 1 represents the equation of an ellipse. The next one is a parabola, that is y square equal to 4x and x square equal to 4ay are the standard parabolas. Now let us solve the problems on double integral over a given region. So the given first problem is evaluate a double integral of dx dy by root of square root of 1 minus x square 1 minus y square, where r is the rectangle bounded by the lines x equal to 0, x equal to 1, y equal to 0 and y equal to 1. So using the given curve, we should identify the bounded region R first. So the given lines or given curves are x equal to 0, x equal to 1, y equal to 0 and y equal to 1. Using this, we should represent a rectangle. So consider a coordinate axis. So where x and y axis, and this is our origin, we know that. So and we know that x equal to 0 represents the equation of y axis. On y axis we know that your x equal to 0 and x equal to 1 is the line which is parallel to y axis passing through the point 1, right. So this is our x equal to 1. Next one, y equal to 0. Y equal to 0 is this line, that is your x axis. On x axis we know that y equal to 0. And the last one, y equal to 1. Y equal to 1 is the equation of a line which is parallel to x axis and passes through the point 1, 0 or 1, 1. So we have the points, this is 0, 0 and this will be our 1, 0 and this is our 1, 1 and this is of course 0, 1. So this is your bounded region R. So in this region we should evaluate the given double integral. So the given double integral, before going to consider the given double integral, we should know what is the limit of x and y to evaluate the double integral, right. So we should consider the limit of x on x axis. We always consider the limit of x on x axis, that is x varies from, in a bounded region it varies from 0 to 1. So your x varies between these two values, so x varies from 0 to 1. And we consider the y limit in the bounded region, that means here we consider the y limit. So y varies from 0 to this line. So this line is given by y equal to 1. So y varies from 0 to 1. Therefore, we can write like this. From the figure we note down that x varies from 0 to 1 and also y varies from 0 to 1. So x is considered always on x axis, x limit, and y limit is always considered in the bounded region, right. It is considered in the bounded region parallel to y axis. Remember, the x limit is considered on the x axis and y limit is considered inside the bounded region, which is a line parallel to the y axis. Okay. Now consider the given double integral dx dy divided by square root of 1 minus x square 1 minus y square over the region R. Is nothing but now we know the limit of x and y, right? So before going to write the limit, remember you should represent the constant limits always outer limit. Of course here both the limits are constant. I can write 0 to 1, 0 to 1, and I can write dx dy divided by, I will split the square root as root of 1 minus x square into root of 1 minus y square. I separate that. Since both are constant limit, I can split the double integral as we solved in the previous session, double and triple integral. I can separate this integral 0 to 1 dx by root of 1 minus x square into, since I have a multiple of variables, right, into integral dy by root of 1 minus y square, y varies from 0 to 1. And of course we know the standard integral formula, that is integral of 1 by root of 1 minus x square is nothing but sin inverse x between the limit 0 to 1 into, of course the same value, instead of x we have sin inverse y between the limit 0 to 1. Therefore that reduces to, the given integral reduces to sin inverse of 1 minus sin inverse 0 into sin inverse 1 upper limit minus sin inverse 0. If I apply the upper and lower limit, we know the upper limit is 1, lower limit is 0. So sin inverse 1 minus sin inverse 0, again sin inverse 1 minus sin inverse 0. And we know that sin inverse of 1, the given integral, if I name it as I, then the given integral is given by sin inverse of 1 is pi by 2 and sin inverse 0 is 0. Same thing into sin inverse 1 is pi by 2, sin inverse of 0 is 0. So the given double integral value reduced with pi square by 4 is our result. Now solve the next problem. If R is the triangular region, if R is the triangular region with vertices 0, 0, 2, 0 and 2, 3, then evaluate double integral of x square y square dx dy over the region R. So again, to solve this, consider the given vertices. Instead of a curve, they given you the points. Using the points, we have to represent the curve. Given vertices of a triangle are 0, 0, 2, 0 and 2, 3. Of course, we know how to represent a triangle, right? So consider a coordinate axis, xy axis, okay? So in that represent the point 0, 0 is the origin and 2, 0 is on x axis, x value 2, y value 0, of course it should be on x axis, and another point 2, 3, it may come here 2, 3. Now join all the 3 points. I name it as O, A, B. So we have a triangle OAB and this is our required region R. So now from this we should get the limits of x and y, right? So as we discussed in the previous problem, we know that the x limit is always considered on x axis. X varies from 0 to 2. X limit is considered on x axis. Therefore, x varies from 0 to 2. And we know that y is considered, y limit is considered inside the bounded region. Here y varies and it is a line parallel to y axis. So y varies from the x axis to this line. So we should know what is the equation of this line. So we can find the equation of this line because that line passes through the origin. If I know the slope of that line, then I can write the equation of that line. So I can get the slope of the line because I know the 2 points. If I know the points, end points of the line, I can get the slope of the line using the formula m equal to y2 minus y1 by x2 minus x1. It is nothing but 3 minus 0 by 2 minus 0 is nothing but 3 by 2. Therefore, the line OB, so from figure I can say like this, from figure x varies from 0 to 2 and the line OB, equation of line OB is y equal to mx, where the slope is given by 3 by 2 into x. Therefore, where y varies from x axis, right? So we know the equation on x axis is y equal to 0. So y varies from 0 to, and this line is given by 3x by 2 or 3 by 2 times of x. So y varies from 0 to 3x by 2. So we know what are the limits of x and y. Now consider the given double integral. Double integral x square y square dx dy over the region R is nothing but double integral x square y square. I will write only this part. I am not going to write dx dy now. Before going to write that, we should represent the limit because here the x limit is between 0 to 2 and y limit is between 0 to 3x by 2. So remember, in this case you should consider when we have one as a constant limit, another one as a variable limit, then your constant limit should be a outer limit and variable limit should be the inner limit. In that order we should consider the limit. Therefore, outer limit is x limit, it varies from 0 to 2 and inner limit is y limit, it varies from 0 to 3x by 2. Therefore, what we should write first? So, x square y square dy then dx. Okay. Now, integrate with respect to y keeping x constant, that is integral 0 to 2 x square constant, integral of y square is y cube by 3 between the limit 0 to 3x by 2, dx remains as it is. Now apply the limit. So x square by 3 is constant, upper limit is 3x by 2, so 3x by 2 whole cube minus lower limit is 0 and dx remains as it is. Now simplify before going to integrate with respect to x, that is x square by 3 into 3 cube into x cube by 2 cube minus 0. So take out the constant values, that is 3 one time get cancelled, I remains with 9 by 2 cube is nothing but 8, integral 0 to 2 x cube into x square is nothing but x to the power of 5 dx. Now integrate your x cube, that is 9 by 8 equal into x to the power of 5 integration x power 6 by 6 between the limit 0 to 2, or 9 by 8 into 6 common 2 to the power of 6 minus 0. So if I simplify this, we have 8 in a denominator, 9 by 6 nothing but 3 by 2 into 8. So into 2 to the power of 6, or we have 2 power 3, 8 is nothing but 2 power 3 into 2 power 4. So I can cancel here 3 times, so that I left with a 2 square is nothing but 12. Now solve the next problem. evaluate double integral xy dx dy over the region R over the region in the positive quadrant for which x plus y is less than or equal to 1. So, the given curve is x plus y is less than or equal to 1. So, consider the given curve given x plus y is less than or equal to 1. So, we should represent this line. It is nothing but a straight line. Consider a coordinate axis, x axis, y axis and origin. Now represent that line. It is nothing but the intercept form of the line x plus x by 1 plus y by 1 equal to 1. So of course they given you to consider in a region or in a positive quadrant, right? So we can draw the line like this, x plus y. This is your line x plus y equal to 1, which makes the x intercept 1 comma 0 and the y intercept 0 comma 1. So this is our bounded region R. So from this we should get what is the x and y limit, right? So we know that the x limit is considered on x axis, therefore x varies from 0 to 1 in between these two. So x varies from 0 to 1 and y varies from x axis to the given line in a bounded region, and it is a line of course parallel to y axis. So y varies from x axis to the given line. So we should know what is the limit of x and y, right? X varies from 0 to 1 and here y is 0 and represent here what is y? X plus y equal to 1 we have. So I can rewrite this as y equal to 1 minus x. So y varies from 0 to 1 minus x. Therefore, I can write from figure, once you represent the given curve and a bounded region, we can get the limits of x and y. From figure, x varies from 0 to 1 and y varies from 0 to 1 minus x. Now consider the given double integral, that is consider, I call it as I equal to double integral xy dx dy over the region R. Replace your limit integral, double integral xy, I am not going to write dx dy, right? So what should be the outer limit? Yes, outer limit is 0 to 1 and the inner limit must be the variable limit 0 to 1 minus 6. The variable limit should be inner limit and the constant limit should be the outer limit. Therefore, y varies from 0 to 1 minus x, dy we have dx, then therefore the outer limit 0 to 1. Now integrate with respect to y, keeping x constant, integral 0 to 1 x constant, integral of y is y square by 2 between the limit 0 to 1 minus x dx. So 1 by 2 common, integral 0 to 1 x into upper limit 1 minus x whole square minus lower limit 0 into dx. Now simplify before going to integrate. So I name it as I, right? I equal to 1 by 2 integral 0 to 1 x into, expand your in 1 minus x whole square using a minus b whole square formula, that is 1 plus x square minus 2x dx. So we have 1 by 2 into integral 0 to 1 x plus x cube minus 2 x into x square dx. Yes, now I can integrate with respect to x, that is 1 by 2 into integral of x is x square by 2 plus x cube integration x power 4 by 4 minus 2 times of x square integration x cube by 3 between the limit 0 to 1. Apply the limit now. 1 by 2 into upper limit 1, 1 by 2 plus 1 by 4 minus 2 by 3 will be the upper limit, x value 1, and the lower limit is 0, x is 0. Simplify this, that is 1 by 2 into, simplify this, 1 by 2 plus 1 by 4 is nothing but 3 by 4 minus 2 by 3, or if I take LCM, then we have, if I take LCM between 3 and 4 and simplify, we have 1 by 2 into 9 minus 8 by 12, or it is nothing but 1 by 24. So our required result is 1 by 24. Now solve the next problem. Evaluate double integral xy dx dy over region R, that is, the region is over the positive quadrant of the circle x square plus y square equal to a square. Now the given curve is a circle. We should represent a circle, then we should get the limits of x and y. So the given curve is x square plus y square equal to a square. So consider a coordinate plane, coordinate axis, that is x and y axis, and we know that x square plus y square equal to a square represents a circle with center at origin and radius equal to a. So draw a circle, right? And now we are supposed to consider only in a positive quadrant. Therefore, we should consider only this part. We have to consider only the positive quadrant of the given circle. So in this we have to get what is the limit of x and limit of y. So this is our point 0 comma a comma 0, because the radius of the circle is a. Therefore your x varies from 0 to a, and of course we know that y should be considered in a bounded region, and it is a line parallel to y axis in the bounded region. So this is our y limit. So we should know what is this curve. It is nothing but a circle, but we should represent that in terms of y. What is the limit of y? So consider the given circle y square, x square plus y square equal to a square. So get your y square is a square minus x square, or y is plus or minus root of a square minus x square. So in this we should consider y equal to positive times of or plus x square minus y square, because we are supposed to evaluate in a positive quadrant. So neglect the negative result, consider only the positive one, that is y varies or y is nothing but root of a square minus x square. Therefore from figure, x varies from 0 to a, and this surface is nothing but root of, or y equal to, this is nothing but y equal to root of a square minus x square. So x varies from 0 to a and y varies from 0 to root of a square minus x square. Now consider the given double integral. I consider it as I equal to double integral xy dx dy over the region R, or it is equal to double integral. So as we know, the constant limit must be the outer limit, and the variable limit should be the inner limit. So 0 to a and 0 to root of a square minus x square xy dy dx. Now integrate with respect to y, keeping x constant, that is integral 0 to a x is considered constant. Integral of y is y square by 2 between the limit 0 to root of a square minus x square dx, or it's equal to 1 by 2 is considered common. 1 by 2 into integral 0 to a x into upper limit is root of square root of a square minus x square whole square minus 0 into dx. So, root of a square minus x square whole square is nothing but a square minus x square. So, I remains with I equal to 1 by 2 into integral 0 to a x into a square minus x square dx. Multiply by x and then integrate 0 to a square x minus x square into x will be x cube dx. Now integrating with respect to x, 1 by 2 common, a square is constant, integral of x is x square by 2 minus integral of x cube is x power 4 by 4 between the limit 0 to a. Now apply the limit, that is 1 by 2 into a square by 2 common, upper limit is a square minus lower limit 0 minus 1 by 4 common, upper limit is a, so a to the power of 4 minus lower limit 0. So we remains with 1 by 2 into a to the power of 4 by 2 minus a to the power of 4 by 4. So a power 4 is common, then 1 by 2 minus 1 by 4 is nothing but 1 by 4. So 1 by 2 into a power 4 by 4. So the required result is a to the power of 4 by 8 is our result. Now solve the next problem. Evaluate double integral xy into x plus y dx dy taken over the given region is taken over the region enclosed by the curves y equal to x, enclosed by the curves y equal to x and y equal to x square. So consider the given curves. Given y equal to x and y equal to x square. So what are the given curves? Yes, y equal to x is the equation of a straight line passing through the origin and making an angle 45 degree with the x axis. And what is our y equal to x square? Yes, y equal to x square is the equation of a parabola which is symmetric about y axis, right? So represent both the curves in a quadrant coordinate plane, that is x and y axis. So we have y equal to x, that is equation of a line passing through the origin. This represents y equal to x is the line passing through origin. Now another curve y equal to x square, or x square equal to y is the equation of a parabola which is symmetric about, this is your y equal to x square. It's a line or is a parabola symmetric about y axis. Now the bounded region is this one. This is our bounded region R. So in the last problems or in a previous problems, we will get the points on x axis. Now in this case we don't have any point on the x axis, right? So how to get the points? At the point of intersection of the given curve, we should consider the given curve y equal to x and y equal to x square and solve them, then we can get the point of intersection. So I replace y by x square. So x square equal to x or x square minus x is 0. If I take out x common, I remains with x into x minus 1 is 0, which implies x equal to 0 and x equal to 1. So we have 2 points, x is 0 and x equal to 1. So if x is 0, of course y is also 0. If x is 1, y is equal to 1. Therefore the points are 0, 0 and 1, 1. So these two are the point of intersection. 0, 0 and 1, 1 are the point of intersection. So from this I can get the point on x axis if I represent like this. So we have a point on x axis is 1, 0. So as we know, our x always varies on x axis. So x varies from 0 to 1. And where we should consider the y limit? Yes, we must consider the y limit in a bounded region, and of course it is a line parallel to y axis. So y varies from parabola to the line. So y varies from this parabola to the given line, y equal to x. From the figure I can represent like this. From figure, x varies from 0 to 1 and y varies from x square to x. So this is your y equal to x square. So y varies from x square to x. Now consider the given integral as I. I is double integral xy into x plus y dx dy over the region R. Right, replace your limits. Apply the limit or substitute the limits. Of course, the constant limit should be outer limit and variable limit should be inner limit. So the constant limit is 0 to 1 and the variable limit is x square to x, and we have xy into x plus y. I multiply them, that is x square y plus xy square into, since I have x square here, that is y limit, so I should write first dy and then dx. Now keeping your x constant, integrate with respect to y, that is I is integral 0 to 1 x square constant, integral of y is y square by 2 between the limit x square to x plus x constant, integral of y square is y cube by 3 between the limit x square to x dx. Now apply the limit and simplify, that is integral 0 to 1 x by 2 constant, upper limit is x square minus lower limit is x square whole square, that become x to the power of 4 plus x by 3 constant, here x square by 2 constant, x by 3 constant, upper limit x, that is x cube, minus lower limit is x square whole cube, it become x to the power of 6. Now simplify before going to integrate with respect to x, that is integral I equal to integral 0 to 1 x square into x square x to the power of 4 by 2 minus x to the power of 2 into x power 4 x power 6 by 2 plus x power 4 by 3 minus x to the power of 7 by 3 into dx. So I can simplify these two. 1 by 2 plus 1 by 3 times of x power 4 we have. So I can take out x power 4 common, so that 1 by 2 plus 1 by 3 will be 5 by 6. So integral 0 to 1, 5 times of x power 4 by 6 minus x to the power of 6 by 2 minus x power 7 by 3 should be integrated with respect to x. So 5 by 6 common, integral of x power 4 is x power 5 by 5 between the limit 0 to 1 minus 1 by 2 into x power 7 by 7 between the limit 0 to 1 minus 1 by 3 into x to the power of 8 by 8 between the limit 0 to 1. Now simplify this. So 1 by 6 into 1 minus 0 minus 1 by 14 into 1 minus 0 minus 1 by 24 into 1 by 24 into 1 minus 0. So, we remains with 1 by 6 minus 1 by 14 minus 1 by 24. So, if I take LCM and if I simplify this 1 by 6 minus 1 by 14 minus 1 by 24, we remains with 3 by 56. So, the required result is 3 by 56.